guys, hi, welcome back to my channel Net Physics. And if you're watching this video for the very first time, then I would request you to please subscribe to my YouTube channel and also hit the bell icon. In this video we shall discuss the questions of CSIR net examinations, and these questions are of nuclear physics, and we will discuss the questions of June 2011. So let's start. The first question is that the radius of copper 2964 nucleus, it is measured to be 4.8 into 10 to the power minus 13 centimeter, and the radius of magnesium 1227 nucleus can be estimated to be, means here we are having the radius of this nucleus copper and we are asked to find the radius of this nucleus magnesium. So whenever we have the radius of one nucleus and the mass number of both the nucleus is given, then we can find the radius of the other nucleus by using the formula nuclear radius. Okay, the formula for nuclear radius, which is R is equals to R naught a to the power 1 by 3. Here R naught, it is a constant and it is equals to approximately equals to 1.2 for me, and A is the mass number here and R is the radius of the nucleus. Okay, so what we will do, we will take the ratio of the radius of magnesium by the radius of copper. So here we are having R naught, mass number of magnesium whole to the power 1 by 3, and R naught, mass number of copper whole to the power 1 by 3, and this R naught will get cancelled, and here the mass number of magnesium, we know that this 64, this part, okay, it is XZA. Z is the number of protons, A is the mass number, and X is the nuclide. So here we will see the mass number for magnesium is how much? The mass number of magnesium is 27 and the mass number of copper is how much? 64. So we will write here the mass number of magnesium to be 27 and the mass number of copper to be 64 and whole to the power 1 by 3. So if you see here, you can write 27 as 3 cube and 64 as 4 cube. So which will give us only 3 by 4 because the power will get cancelled here. And the radius of magnesium, it is equals to what? Radius of copper into with 3 by 4. Radius of copper was given 4.8 into with 10 to the power minus 13 centimeter, and here this 4 will get cancelled with this 4.8 and we will have 1.2. So finally the radius of magnesium is 3.6 into 10 to the power minus 13 centimeter. So the correct option is option C. These questions are very simple and this is a very basic formula of nuclear radius. So you can just use and find the radius of any nucleus given to you. So now let's come to the next question. Here in the next question we have the root mean square energy of a nucleon in a nucleus of atomic number A in its ground state varies as. Means we have to say how the root mean square energy of a nucleon in a nucleus varies, okay, whose atomic number is A, and in its ground state how it will vary. So the energy of the root mean square energy of a nucleon, it is proportional to what? 1 by R, means it is inversely proportional to the nuclear radius. We know that the formula for nuclear radius is what? R naught a to the power 1 by 3. That means the energy, the root mean square energy of a nucleon, it is proportional to what? A to the power minus 1 by 3. So the correct option is option C. Now let's come to the next question. So the next question is that a beam of pions, pi positive, it is incident on a photon target and is giving rise to the process pi positive proton gives n plus pi positive is neutron. So the question is, assuming that the decay proceeds through strong interaction, we have to find the total spin I and its third component for the decay product. So we are having 4 options here. So for this, what we will see, the reaction is what? The reaction is pi positive proton, okay, it is giving what? Neutron plus pi positive plus pi positive, right? So the decay product is what? Neutron, pi positive and pi positive. Neutron is what? A doublet, so its isospin is what? Half, and pi positive pions are what? Triplets, so its isospin is what? 1, and the third component I3 for neutron is minus half, and for pi positive it is plus 1. So you can see here, this will give us a total 5 by 2 and this will give us a total 3 by 2. So I is equals to 5 by 2 and I3 is equals to what? 3 by 2. So the correct option is option C, right? The correct option is option C here. Now let's come to the next question, which is the last question of this video. So here we are having that using the isospin symmetry, okay, the cross section for the above process, okay, can be related to that of the process. Means using the isospin symmetry, we have to relate the cross section, okay, for the above process to these four equations. Okay, firstly I would like to say here, whenever we are talking about isospin symmetry, we have to always remember that for isospin symmetry, the particles are always replaced by its antiparticles. Now for the reaction of particles, okay, for the particles the reaction is what? Pi positive proton gives neutron plus pi positive plus pi positive. Now when we will write the reaction for antiparticles, we have to just do one simple thing, is that we will replace all these particles with their antiparticles. So you can see for pi positive, its antiparticle is what? Pi negative. For proton is p bar, and the antiparticle of neutron is antineutron, and pi positive is pi negative and pi positive is pi negative. So we can see here that the correct option is option B. So these are very simple questions. The only thing which is required is that your concept and the basic things must be clear. So if you loved this video and it was helpful for you, do share with your friends. Do not forget to hit the bell icon. Also subscribe to my YouTube channel, leave your comments and all the necessary suggestions or advices that you want to give me. Thank you so much. Have a good day.